This is brought to you by the Alumni Association of PISJ-ES.
Hey guys, we're back with the same topic that we were discussing earlier, a very important part of the kinematics topic, acceleration. And I left you with the numerical method in the earlier video where we learned how to calculate acceleration numerically. So acceleration was simply change in velocity divided by change in time, or velocity, final velocity minus initial velocity divided by time. So this was acceleration. Again, there was one more thing that I wanted to discuss with you guys, was a case here. For example, we discussed cases earlier that when the speed of a car increases or decreases in any manner, it just changes even with 0.0001 millimeters per second, we say that it accelerates. What about if a car is moving in a circle with the same velocity at every point, say A, B, C, and D? It has the same velocity at every point, but it is moving in a circle. What do you think? Is it accelerating or no? Well, the answer to this question is yes, it is accelerating. Always remember that even if one of the two changes, the magnitude changes, even if the magnitude changes and the direction remains constant, we will say that it is accelerating. Or if there's a change in direction, even if there's a little bit of, if it only curves from here to here with the same velocity, for example, it has the same velocity here and the same velocity here, if it just takes a turn, if there's a change in direction, even if the magnitude is constant, we will say that it is accelerating. Okay? Or the velocity has changed, because velocity is made up of two things, the magnitude and the direction. So both of them are important. If there's a change in magnitude, there is acceleration. If there's a change in direction, there is acceleration. So always remember that, guys. And now we'll be moving on to a little quiz that I have here with you. So we'll be doing some examples and then we'll be scoring ourselves and we'll see how well we are prepared with it. So sorry, I have a little quiz here for you guys. So let's see if you are able to see it correctly. Let me just yeah, so I'm sure you are able to see it correctly. So this is just a website and I'm just taking a quiz here with you guys. So let's see if we can score a good score. So the first question, how long does it take for a car to change its velocity from 10 meters per second to 25 meters per second if the acceleration is 5 meters per second square? So our first question, we have our data. It's always a good habit to make the data. So it says, how long does it take to change the velocity of a car from 10 meters per second? So we know the initial velocity is 10 meters per second to 25 meters per second. If the acceleration is, let me have a look, 5 meters per second square. So the acceleration is 5 meters per second square. So what are they asking for? They are asking for the time. How long? So for acceleration and velocity, we have just one formula, which is A is equals to V minus U over T. Okay, my pen is acting up. I don't know why. So just bear with it. I'm really sorry about it. So anyway, this would be 25, which is the final velocity, minus the initial velocity, which is 10, divided by T, since we have to find this out, is equals to A, which is 5. So let's just switch 5 with T, since it's a common denominator, we can take it here and take the 5 here. So this would be 15, 25 minus 10 is 15, divided by 5, is equals to t, t is equals to 3 seconds. So our answer is 3 seconds. Let's just put it here, 3 seconds. Okay. Let's move on to the other example. We'll do this at the very end, or probably in the next video, because this is a long one. So we'll do this in the very end. Okay, so let's see this one. A car has a constant acceleration of 4 meters per second square starting from rest. So there is a car which has a velocity of an acceleration, sorry, if I'm right, acceleration, a constant acceleration of 4 meters per second square starting from rest. So initial velocity is 0 meters per second and acceleration is 4 meters per second square starting from rest. How fast is it traveling after 5 seconds? So they're asking me the final velocity after 5 seconds. T is 5 seconds. Let's just put it in our formula here. So this would become, now we do not know the V2 or the V final. This is our formula over T is equals to A. Okay, so we do not know this, so let's make this the subject. This would become V2 minus V1 is equals to A times T, and then since we have to make this a subject and this is subtracting, we'll take it over here. V2 is equals to A times T bracket plus V1, since this is adding to the multiplication, to the product of this. So V2 is equals to, now substitute the values, 4 times 5 plus V1, which is 0. So V2 is 20 meters per second. It would be traveling with a speed of 20 meters per second if it has an acceleration for 4 meters per second for 5 seconds. So every second it would be, the speed would be increasing with 4 meters per second. So the first second would be 4, second would be 8, third 12, fourth 16, and fifth 20. Yes, so this is 20 meters per second. Now it's asking again a question from velocity. It says, how far is it traveling after 5 seconds? How far is it traveling after 5 seconds? So how far is it traveling after 5 seconds? We know we have the initial velocity, which is 0 meters per second. We have the final velocity, which is 20 meters per second. So we know the formula to calculate the distance. Distance is equals to velocity times time. So it is, since the time is 5 seconds, and first, but this is average, so we will have to find the average of this. So distance is equals to 20. Now I'm finding the average, 20 plus 0 divided by 2. This is the average, V2 plus V1 divided by 2 times 5. 20 plus 0 is just 20, divided by 2 is 10. So D is equals to 10 times 5, which is equals to 50 meters. So it would be 50 meters. Now it's asking me how far has it reached. So basically this part is a little out of the topic here, and even this one, because we were giving the inaccurate answer, and there's one more formula that you will learn in the higher part, but I just told you how to do it the inaccurate way. But this one is a little out of your course, so we'll just leave it here. We'll just move on. The next question. How long will it take for a falling object to reach 108 meters per second if its velocity is 10 meters per second? So in this case, the question says, example number 3, the question says, how long will it take for a falling object to reach 108 meters per second if its initial velocity is 10 meters per second? Now, you would know that for our basic physics, that if this is the place where it's falling from, and when it's falling, only the gravitational acceleration is acting on it, which is, just for now, just assume that the downward acceleration is 9.8 meters per second square, or let's for simplicity just assume 10 meters per second square. It has an acceleration of 10 meters per second square downwards because of the gravity. So its initial speed v1 is given as 10 meters per second, and they are saying how long will it take before the final speed reaches 108 meters per second. So now let's get back to our formula. Acceleration is equals to v minus u divided by t. Acceleration is 10 meters per second, we need the time, so we'll just change the subject. T is equals to v minus u divided by a. V is 108, this is the final velocity, and sorry for if you're confused here, this is the initial velocity. This is always final velocity minus initial velocity. So this is 108 minus 10 divided by 10, the acceleration. So if you find out this is 9.8, time is equals to 9.8 divided by 10, sorry, 98 divided by 10, 108 minus 10 is 98 divided by 10, which will give us 9.8 seconds. If you take this value, the more accurate one, it would be something like this: 108 minus 9.8 divided by 10, sorry, 108, what am I doing here? Wait. This would become something like this: 108 minus initial velocity is 10 divided by 9.8. This would become 98 divided by 9.8, which would simply be 10 seconds. So any of the two answers could be correct. We'll just put in 10 seconds because it's more accurate. So just a little 10 seconds. The seconds is here already. So we cannot do this question again because this is something that we haven't done and we won't be doing till your higher levels. So we'll just skip this one. Let's see if our answers are correct. So it says you only got 4 out of 9 correct, which means we have left 5 questions. This one is correct. This one is correct. Both of them are correct. This one is also correct. So we have got the ones that we attempted, we have got all of these correct. So that means we are pretty much on the right track here. So guys, we'll be doing much more difficult examples in the future. So just keep revising with the formula for acceleration. For velocity, first of all, the formula is distance divided by time. Just a review where you can switch the formula to v over d. Oh, no. So guys, just a review. For velocity, the formula is v is equals to d over t. For time, just switch the formula d over v. For distance, velocity into time. For acceleration, the same formula here, the velocity is average. For acceleration, the formula becomes velocity final, or the final velocity minus initial velocity over change in time, which means delta v over delta t. And remember, if there is a change in magnitude or a change in direction, we can say that there is acceleration. So it accelerates. So guys, I hope you would be pretty much getting the hang of it. If you have any queries, just put it down in the comments box and I will be reading them and I will be replying to them. So thanks for watching, guys.